Good afternoon, everyone. Our group is composed by me, Matteo, Aris, Andy, and Pravin, and we are going to talk about active sensing for robotics. In literature, when we talk about sensing, we can find passive localization, active localization, and active sensing. The big difference between the group of active localization, active sensing, from passive localization is that passive localization regarding a robot is just a robot taking information from data. It don't communicate at all with the controller. It just localizes itself. In our research, active localization and active sensing are joined together. Active localization in what to do next, and active sensing where to position ourselves. Active sensing is a decision-making process. So it permits to a robot to have a certain history and to compute a certain trajectory. My group and I make a little graph to understand better where to put our active sensing decision-making. It's between the estimator and the controller. So we take directly information from the estimator and talk to the controller to get an optimal trajectory. Our presentation, we focus on uncertainties, optimization algorithm about active sensing, and multi-agent system. Active sensing so becomes an optimization problem that focuses on where to position the sensor in our robot and how to maximize our information, minimizing the cost, and to make this information useful. In a mathematical world, we can end up with this value function that is a weighted sum of computational load, can be time, energy, or number of operations, and uncertainty. Now, looking at the parameter of uncertainty, we all know that nobody wants uncertainty. So, to measure that, to make a model of that, there are two different methods, and the first of these use a covariance matrix on the prior distribution on the state. Because when we talk about uncertainty, we talk about uncertainty on the state estimate. So when we look at the covariance matrix, it's exactly a measure of uncertainty of our state. Minimize that corresponds to minimize uncertainty. There are several criterions, and they have a little trade-off between allow to verify the task completion, so to get exactly where we want to go, and to be invariant when it transformation on the vector x, or the vector, sorry, the vector space. For another method is to look at entropy, and the entropy becomes taking account the whole covariance matrix of our estimate and make a probability function that, and measuring that, minimize that corresponds again to minimize the uncertainty. The disadvantage of this entropy is that taking account all the uncertainty of the state, so get more information, but it requires more time. So again, these two methods, we can decide which, for every situation, we can decide which is better or not. Okay, looking at the optimization algorithm for this active sensing, there are two categories of that. One, when the second of action is parameterized, is restricted to a parameterized trajectory, and another when it's not. Looking at the first example, when we have a parameterized trajectory, when our robot has to go, in one case from Calafiore, it takes as a class or jump position time function and create this trajectory. What active sensing does, it takes a lot of information from this trajectory and create a calibrated experiment. Because from this trajectory, then in this paper, they focus on discover the dynamical structure of the robot, and they use genetic algorithm that takes in account all the constraints during the decomposing phase. So it takes in account the acceleration constraint, the velocity constraint, and etc. Another case of active sensing with a parameterized trajectory is when having a robot and we want to go from one place to another place. We have a nominal trajectory and we modify that using superposition of sinusoids. So we excite in this trajectory and we made new trajectory from that with multi-sign function. These multi-sign functions are good because they are rich, exciting signal, and also that makes this problem finite computational load. But the disadvantage of that is in a change on this trajectory, that becomes a global change. So we have to be careful on that. Paris is going to talk about other algorithms.